let's understand the new topic, which one, types of matrices. Okay, so there are different type of matrices. So first we introduce, so the matrix, we know what is the matrix. So matrix is a arrangement, like it is a rectangular arrangement. Rectangular arrangement basically, we can say the rectangular array. So the types of matrices can be obtained by different type of arrangement. Okay, so if I use the normal matrix, for example, say this one, the matrix A B C D E F. Okay, what is the arrangement I use? A B C E F Z and 1 2 3. So these are all my example element of the matrices which we obtain from these. Okay, first arrangement. Okay, so if I arranged all these numbers into one row, then what have happened? Like A, I use these 5. Okay, A, no, all, sorry, I use only these 3 for not messy. Okay, so A B C. Okay, if I use to another, which is E N F. Okay, so it is the arrangement of 5 element in the line way. So what do you think after this arrangement? It is a column type like this. So this arrangement is like a column. So we say that this is the column matrix. Okay, column matrix. Sorry for my English spelling. Okay, now if all these 5, the column arrangement, column matrix. Okay, the second arrangement I say array. Okay, if I arrange all these 5 into the line, but now horizontally, so the horizontally become A B C E and F. Okay, so now it is a horizontally, so it is like a row. Okay, so this is called the arrangement like in row, so it is called row matrix. Okay, now third arrangement, I say third arrangement. If now I use, instead of single, I use the multiple line, but in vertical way. So it's like a B C D E F or many more, like from this, but not in square way. So this type of arrangement called where m is not equal to n, then this call, like we can say that it is a horizontal vertical matrix, because it is arranged like a vertically. And the fourth one, we can say that if simply for tilt together, this become A B C D E F 1 2 3. But this type of arrangement, that m is not equal to n, then this arrangement looks like an horizontal, so we can say that this is the horizontal matrix. Okay, now the second type of arrangement, we discussed the fourth. Now the fifth one. Here is the main concept. Okay, the fifth one, arrangement. Say array. So if I arranged all these, so like see A, B, C, E, F, Z, 1, 2, 3. So this arrangement is like a square because all these line, row and columns are same, so it will become a square. So this looks like a square matrix, like a square arrangement, so that's why we called square arrangement, basically the square arrangement. But we called matrix because arrangement are also matrix. So this is the called square matrix. Okay, the some properties of square matrix is like a square matrix. Okay, so like a square, this area, we know that in the square this is called diagonal because all the entry above and all the entry below, say this is A, say this is B, so A is equal to B. The line which divide the bisect the all these parts in the same area, so we call this is the square. So like if we add two triangles the same length, we create a square. So similarly for this, if I say that this is the line which the line basically this which bisect the square matrix, like all the element 1 2 3 number of element in both sides same, it is called the diagonal of a matrix. Okay, so the diagonal of a matrix is equal to diagonal of a matrix and it is always on a square matrix. Okay, which is diagonal and it is A, F and 3 because it bisect the all number of element in both sides the same part. Okay, diagonal element it is only on the number point, it is only in square matrix, we seen only square matrix. Okay, second thing, we know the square matrix, the basic definition. Okay, the basic definition for general definition. Okay, so the definition, we can say that if A is a square matrix, so Aij, any matrix can denote it in Aij form, because if we say Aij, save A1 for example. Okay, once again, suppose I say Aij is a matrix, any like any A is a matrix, so we denote A is equal to Aij M cross n, where M and the order of matrix and Ij are the row and column, where I is equal to row and J is equal to column. Okay, so if why we call, for example, if say I is equal to 1 and J is equal to 1 and we say I is equal to 2, J is equal to 1 and I is equal to and 1 1, J is equal to 2 and this is equal to 1. Okay, what I am saying that you understand. Okay, I say Aij, so A11, say A12, A21 and I2 J21 and that is A22. So this create a horizontal matrix with the 2 row and 2 columns, no sorry, square matrix of 2 row 2 column and say 2 by 2. Similarly for say A31 and A32, now it become, we can say that vertical matrix or simply vertical matrices. So in say we now the order change and it become 3 by 2 order, 3 rows and 2 columns. So this is the basic foundation of create a matrix. Okay, now Aij is a matrix of M cross M. So if M is equal to n for all I comma j, ठीक है. Then we can say that a is equal to aij m into m is a square matrix. Okay, then A is the square matrix. It is the basic definition of square matrix. I hope you understand what is why we call this is a square matrix. Okay, and some fact like in a vertical matrix. So in the vertical matrix we can say that in this vertical matrix, like if I am saying, understanding together, this is our vertical matrix. So why we say that it is a vertical matrix? We can say that if the number of row is greater than and the column is less than the number of rows, like if m is greater than n, then what happen? For example, say m2 and n1, then say 2 3. Here m is 2 and this become a vertical matrix of one entries, one column. Okay, if I say this is 3 and this is 2, what happened now? Say 1, this is 3. Okay, so 1 2 3 and this is 2, and so n is number of columns. So it is say 1, and second thing is say a b c. Now it is again a horizontal vertical matrix with the 2 row columns. So we can say that if m is greater than n, then the matrix, the arrangement is called vertical. Okay, and so now we can, from this we can say that if m is less than n, then the arrangement is horizontal. I hope you understand what I said. We prove for m is greater than n, it become a vertical. So for less than is horizontal. See, if m1 and this is 2, now this is 1 2, so this become a horizontal. Similarly, if I say this is 2 and this is 3, say 1 2 3 maximum, and this is 2, so a b c e, that is, we can say that so now number of rows. But we can also say that, for example, in a horizontal matrix, vertical matrix, okay, we have m is greater than n. If we flip it, now the number of row, where is this flipping, so this row become now columns. Identity change also, so this is become horizontal and the identity is also flipped, the inequalities flips. Now this create n, so we can also say that with rotation. Okay, so sorry for that. So we can say that m is for horizontal, m is less than n, and for vertical m is greater than n. Okay, and okay, the second part. Okay, we have now square matrix. Okay, if we understand the new things. Okay, now okay, once again. Okay, the second thing is the diagonal matrix. Diagonal matrix, it is the diagonal of square matrix. Now we talk about the diagonal of matrix. So we know diagonal is always on the square, because if we have a square, then it is a diagonal. Okay, now understand what is the diagonal matrix. Okay, if for a diagonal matrix, we have a square matrix which have only diagonals. That's why we call the diagonal matrix. For example, this is a, this is b, this is c, and so on, this is z. Okay, now for diagonal, it is the diagonal because the number of element in here and the number of element in here are same. If imagine this is a, no sorry, this is lambda and this is mu. So for the diagonal, lambda is equal to mu. If lambda and mu is not equal to 0, then what happen? So in this case we can say that this is the diagonal matrix, and we can say that since this is not 0 and the diagonal also not 0, so diagonal we say gamma, so gamma is not 0. So in this case we can say that the diagonal matrix, this is for example 1 2 3 4 5 1 2 1 2 3 and this is 4, okay, whatever else, okay, and say 5 and 4. I randomly put it, okay. No, this is a not create, 1 second, I creating, okay. Now this is the diagonal, and since this is the not 0 part, what is say lambda which is not 0, and this is the mu which is not 0, so in this case is become the square matrix, but we call about the diagonal matrix. So if the case 2, if I say lambda and mu is equal to 0, then so since we know that the lambda is equal to mu is equal to 0, so we can say that the our matrix now, and also the gamma is not equal to 0, gamma is 0, then nothing happen, okay. Yes, now this part is 0 and second this part is 0, so only we have the diagonal part. Now we can say that it is a diagonal matrix because it has only the diagonal part, so it is called the diagonal matrix, and we successfully found that, okay. So the diagonal matrix, the diagonal. Next we discuss what happen if diagonal is 0, okay. So diagonal of M square matrix, we just prove, we just obtain this, okay. I'm not creating the definition, I'm not putting the, okay, we just create diagonal of a matrix, of a square matrix is not 0, is not 0, and the remaining part is 0. So in the definition, if D is a diagonal matrix, so we can say Aij, since a diagonal entry square matrix M is equal to N, and we know in the diagonal, so here, okay, so in the diagonal, so for square matrix, okay, so the diagonal has same value. This is for A11, A12, A13, A21, A22, A23, A31, A32 and A33. So the diagonal has same I, J. That's why we got diagonal, the upper part, lower part of it. So we can say that for I is equal to J, so if this is diagonal matrix, so we can say that I of M into M, because M is equal to N, the I is equal, I not equal to J part is 0 and I is equal to J part is not equal to 0, then we say that this matrix is called diagonal matrix, and we denote it by the diagonal dia, or dia 1 2 3, or simply diagonal 1 2 3. And also we can see the value of diagonal matrix, value of diagonal matrix, it is 1 2 3 all multiplied, okay. Proof, for example, we have 1 2, sorry, if we have 1 0 0 2, then the value of diagonal is 2 into 1, because diagonal of 1 comma 2, it is 2 into 1 1. Okay. I hope you understand, okay. Here, okay, now what happened, our question, if gamma is equal to 0, let's understand what we called it is. So last part, the remaining part we will discuss the next class, okay. So for I use 2 by 2, so if say 0 0 and if the first part is not equal to 0, okay, then say a b t, sorry, a, okay, so then what we called, we will discuss in next class, because it is become a new matrix. What we call, we will discuss in the next class, okay, what we call. But basically it is nothing, it is a square matrix. And for if this happen, I just say it is a square matrix. And what happen if 0 0 and 0 0, we will discuss in the next class. Both cases, what happen when it is 0, and case 2 the gamma is 0. So in this case what happen, we will discuss in the next class. So I hope you understand. The remaining part of 2 to 3 matrices we will discuss in next class. I hope you understand. Bye bye. Have you any doubt, sorry, please express in the comment section. And if you understand the topic, please like and subscribe if you understand, and give feedback.